All right. So for completing the square, we're basically moving back into quadratics a little bit, right? Um, we're finishing up that unit. And if you remember, what we were doing was we were solving quadratics of the form where we had ax squared plus bx plus c equals 0, right? Where a is always the coefficient of our squared term, our squared variable. B is always the coefficient of our x term, or non-squared variable. And c is our constant, right? Not containing a variable, just a number. Um, the steps for completing the square, I will write down before we actually start. And they may not make sense until you actually see them in practice. But first, we want to write the equation set equal to 0. Right? Basically put it in standard form. So if we have stuff on both sides of the equal sign, we want to have everything on the left-hand side so that it is set equal to 0 on the right-hand side. Number 2, if necessary, divide everything by the A term. Oops, I should probably write that letter A, not just pretend in my mind that I wrote it. What is the A term? It's whatever's in front of x squared. So what I mean by if necessary, if I have just an x squared, not necessary, right? There's no number in front of that x term. So it's 1. And if I divided everything by 1, nothing would change. But if there was like a 2x squared, I would want to divide everything by 2. We want to divide that 2 out so that what's happening is that we're left with just that x squared. That's all right. I usually send out an email before lunch, and I forgot today too. I got hung up and forgot. So after that, our next step would be to move the constant, which is basically our C term, to the left side, right? Sorry, the right side. My left and rights are all mixed up today. You would think I would be better at that because I'm left-handed, and the left would be the side I was writing on. To the left, there, to the right side of the equal sign. Now, this will all make more sense once we've done a few examples, but I do like to have the steps written out. Once we do that, we're going to complete the square. We're going to complete the square by taking half of our B term and squaring it. And then we're going to add that to both sides of the equal sign. And add to both sides. So basically, whatever, when we have our ax squared plus bx plus c equals 0, we're going to take half of whatever that is, and then we're going to square it. and we're going to add it to both sides. Once we've done that, we're going to factor, because what we get are these perfect square trinomials, and we're going to factor and solve. Now, seems like a lot of steps. They happen quickly. And they're way easier than they seem when they're written out, but I like to have them written out anyways, because I think it can give you cues when you're stuck, when you're in the middle of a problem and you're kind of stuck at what to do next. So I do like to have steps, but what we're going to do is we're going to play with them a little bit, right? We're going to solve some of these problems. Let's do a different color. So if, for example, I have x squared equals negative 21 minus 10x, right? Our first step says for us to set everything equal to 0. Move everything over to the left-hand side so the only thing on that right-hand side is 0. Now, it's going to cause a little repetitive step with us, but it's okay, right? We can always do things twice. Because normally, like, I wouldn't even move this 21 over because I know I'm going to want to have it come back. But for the sake of doing everything right now, I am going to just add both of these, right? I'm going to add 10x. I have a minus 10x, so I'm going to add 10x. I have a minus 21, so I'm going to add 21. And I'm going to add them to this side, plus 21 plus 10x. And I'm going to rewrite this equation. I'm going to have x squared plus 10x plus 21 equals 0. Right? The next step says to divide everything by the a term if necessary. But in this case, there's nothing here for a. Our a is 1, right? We only know what 1x squared is. So we don't have to divide by anything, because if I were to divide each of these pieces by 1, they would be exactly the same, right? Because anything divided by 1 is just itself, just like anything multiplied times 1 is itself. And so we don't have to do that. And the next step says we're going to move the c term, the constant, to the right-hand side. What is our c term in this circumstance? What is our c term? So keep in mind, if I have ax squared plus bx plus c equals 0, and this is how it's represented here, what would be considered our c term? Thank you, Mashka. Yes, 21. So we're going to just move that to the other side. And the way we're going to do that is we're just going to subtract 21. If you remember when we first moved it, I'm like, this feels repetitive because we're just going to have to move it back. That's what I mean. So we just subtracted it from both sides. Why? Because it's the opposite of addition. I can do anything I want to an equation as long as I do it to both sides of the equal sign, so I don't mess up the fact that it's equal. Right? The next step is the completing the square step. It says, complete the square by taking half of our b term, squaring it, and then adding it to both sides. What that means is I'm going to take this b term, in this case, b equals 10, right? So I'm going to take 10 and I'm going to divide it by 2. That's what we mean by take half of it. And then I'm going to square it. 10 divided by 2 is 5, and 5 squared is 25. Did y'all see how I did that? Whatever that middle term is, we're going to take half of it, and then we're going to square it. And that is what we're going to add in. So right here, I'm going to put plus 25. And right here, I'm going to put plus 25. And I can do it because I'm doing it to both sides of the equation. I'm not messing with the equality of this. The whole reason that we do it is because it creates what we call a perfect square trinomial. Now, I can explain to you forever what a perfect square trinomial is, but what I can tell you is that the way that we factor it is that we are going to take the square root of this plus the square root of this, right? So the square root of x squared is x. The square root of 25 is 5. And if you don't know what it is, it's always this thing that we squared to get that number that we added, right? And then we're just going to write it as a square. Why can we do that? Because we've created an equation that fits this pattern that allows us to, right? It's one of those special product patterns that we have, and we created it for the whole sake of being able to solve it this way. Negative 21 plus 25 is just 4. And so now we can just go ahead and solve this equation. And the way we do that, the way we solve anything that's squared, is we just take the square root of both sides. Because when I have this squared and I take the square root, I'm left with just this stuff underneath right here, this x plus 5 equals, now I have the square root of 4, and if you remember, that's going to give me a plus or minus 2, right? Because negative 2 times negative 2 can equal 4, but also positive 2 times positive 2 can equal 4. And so a perfect square of 4 could be made by two things. It could be made by negative 2's, or it could be made by positive 2's. And so the last thing I have to do now is figure out what x is by undoing what's being done to it. And the only thing being done to this x is it's got 5 being added to it. So I'm going to go ahead and subtract 5 from both sides. And I get x equals, well, think about this. I have minus 5 plus 2, but I also have minus 5 minus 2, right? So minus 5 plus 2 gives me negative 3, and negative 5 minus 2 equals negative 7. And so my solutions are x equals negative 3 and negative 7. What those solutions indicate, I know it's been a while since we've done quadratics, but if you remember, these x values that we get as a solution are literally just where we are crossing this x-axis. So basically what it's saying is that this parabola that I graph from my quadratic equation has points on the x-axis at negative 7 and negative 3. And that's what those points indicate. And it's why you have most of the time 2. Occasionally you'll have just 1 point. And what it means when you have 1 point is that that vertex, that turn, that maximum or minimum right here is the only point where it's going to cross the x-axis. Sometimes you'll have none, which is imaginary numbers, but we're not going to get into that today anyhow. But does that make some sense? Okay, I'm going to do a few more examples. Keep in mind, pay attention to the directions when you're doing the delta math. I think I'll do one more example and then I'll open delta math so that you can actually kind of see the way they've got the problems laid out and get an idea of what they're asking for. The good news about delta math is if you don't know how to do something, watch the video, right? Because they always have a little video clip there showing you how to do the problem. So let's look at if I have n squared plus 2n equals 63. Now, I know that our first step says set everything equal to 0, but we're going to have to move. If I do that, it just means I have to move the 63 over and then move it back again to do the second step. So I'm just going to leave it as it is because there's nothing wrong with just having the constant on this side because that's how we get started anyways. It's step 2 would be to put it in this format, right? So as long as the only thing on that side is your constant, don't bother to move it. It just creates an extra step for you. We could divide by whatever our A term is, but again, our A term here, we don't have anything in front of this n, so it's just 1. And if we divided everything by 1, we would be left with exactly what we have. We'd have n squared plus 2n equals 63. And so we've already done 3 steps without doing anything, right? Because if we set it equal to 0, it would have just been moving that 63 or whatever the number was over to the left. Then we would divide by a, but that's just dividing by 1, and everything would have been the same. And then we would have had to move that 63 or 65 or whatever that number was back. So literally, we've gotten through the first 3 steps without having done anything. They were already done. So now we just have to do the completing of the square where we're going to take our b term. Well, our b term is just 2. And we are going to divide that by 2. And then we're going to square it. Now, 2 divided by 2 is just 1. And when we square that 1, we're left with 1. Right? So nothing too hard in that problem. So that is what we're going to add here. We're going to add plus 1 here and plus 1 here. And we're going to be left with this perfect square trinomial that we have created, right? And what it says is that I can take the square root of this n squared. Now say this, well, we won't say that because we're completing the square and we will make it always just be an n term. So my first bit is going to be the square root of n squared, which is just n, right? And then we're going to take the square root of our constant, right, which is 1. And the square root of 1 is just 1. And we're going to write that like that. And we can do it because we created this equation, this perfect square trinomial equation, to be able to do it. The whole purpose is to be able to factor this like this so that we could just take square roots to solve. Equals 64. What's nice about this, 64 is a perfect square, so it's going to give us a nice round number. And now all we have to do is solve. And we solve anytime we've got a square that we've got to solve for, we just do it by taking the square root of both sides. And so what I'm left with here is whatever is in the parentheses. So I'm going to be left with n plus 1 equals the square root of 64, which is plus or minus 8. Because negative 8 times negative 8 equals 64, but positive 8 times positive 8 also equals 64. Right? And the only thing we have left to do is to get that n by itself, right? Because that's what we're trying to solve for. And so I'm just going to subtract the 1 that's being added to it. I am left with n equals negative 1 plus or minus 8. And when I look at that in terms of what are my numbers, I go minus 1 plus 8 is 7. Minus 1 minus 8 is negative 9. And so I get n equals 7 and -9. Does that make some sense? You kind of follow that? I've got a couple of yeses. Good, good, good. So I am not going to do any more sample problems because what I want to do is go over to Delta Math and kind of show you what they're looking for before I let you go, okay? So I'm going to stop the video here because I think you've got a couple of samples and I'm sure there'll be more in Delta Math.